All right, everyone, we're going to look at chemistry lesson 15. So I've done something a little different with things. I made it so there's a whole section just for lesson slides. So you can go here to look at the slides I've prepped for this lesson. And then also I have a separate area for support material. Now there's something new in here. This is the most important part of chemistry right here, the periodic table of the elements. We're going to be doing a lot of stuff with this. So go to support material, have this thing open, and let's look at the slides. I believe there's going to be 3 skills you're going to learn how to do today. All right, so when it comes to the periodic table looking at elements, the atomic number, which we've been calling that Z. When we did our notations earlier, I would give you the Z, the atomic number for an element, and I'd tell you that's the number of electrons. But actually, Z, the atomic number, is the number of protons. I've been giving that to you because unless you're told differently, you can assume an element has the same number of protons as electrons. So that's why I've been giving you Z for your number of electrons, but it really means the protons. So what can happen, though, is you can have an atom with the same number of protons, but different numbers of neutrons. And these are called isotopes. So hydrogen, if it's hydrogen, that means it has 1 proton. There's no exceptions. The moment you have 2 protons, you cease to be hydrogen, you become helium. But you can have hydrogen with 1 neutron, with 2 neutrons. Hydrogen can have different number of neutrons. So the different kinds of hydrogens, we call them different isotopes of each other. They're all hydrogens if they have 1 proton, but different neutrons are different isotopes. And the isotopes will have a mass number we call A. And the way you figure out the mass number is you take however many protons, Z, you have, however many neutrons, N, you have, and when you add your protons and neutrons, you get A, which is your mass number. All right, so what we do, we make something called isotope notation, and this is how you indicate an isotope. And what you do is you put the mass number up on top and the atomic number on bottom. So if we look at the periodic table, here you see oxygen, and in the upper left of this periodic table, in the upper left is the atomic number, how many protons they have. Every oxygen in the world is going to have 8 protons. If you gain an extra one, you have 9 protons, you're now fluorine. If you lose one, you have 7 protons, you're now nitrogen. So if it's oxygen, it has to have 8 protons. And right here, what you'll do is you'll do this isotope notation where you're going to give the element symbol. You're going to give me how many protons go below here. So every time you do oxygen, you have to have an 8 down here. The difference is you'll put the mass number up here. The mass number comes from adding protons and neutrons. So this number will change depending on how many neutrons you have. So let's make this right here the isotope notation for sodium 24 and hydrogen 2. You'll notice that it'll say sodium 24. The 24 it tells you is the mass number. They're not going to tell you the atomic number. Now think about it. Why are you not going to be given the atomic number? What do you think? Take 3 seconds and guess. Why are these problems never going to tell you the atomic number? 1, 2, 3. What's your guess? Hopefully you guessed because this thing will always give you the atomic number. Now what's going to take a while, especially something like sodium. Sodium is not S. S is reserved for this guy right here, sulfur. So what do we think sodium is? And this is where it gets kind of weird. Maybe you think SO or SM or something. Some of these, we use their original Latin name, or we use their name in another language. So sodium is actually Na. All right, and it's 11 is the atomic number. So if you're going to make the isotope notation for sodium, we're going to do this. We're going to do Na. All right, and then look at what we did over here, the example it gave us earlier. When it was oxygen, they put the atomic number down here and the mass number up here. So we are doing sodium 24. So we're going to do Na. The 24 goes up here. And then down here is the atomic number. And what is the atomic number of sodium? Let's go ahead and have a look. Periodic table. Sodium was Na, and it's 11. So that just means you're going to take this, and you put an 11 down here. Okay? Next one they want me to do is hydrogen 2. So I'm going to do an H. The 2 is the mass number, so it goes up on top. And then we're going to look up hydrogen. And hydrogen only has one proton. So H2 or hydrogen 2, it's going to be an H with a 2 up there and a 1 down there, and we're done. All right, so on the assignment, what you're going to need to do for the first problem, it has 4 parts. You're going to need to take a piece of paper and draw these on a piece of paper, all right? And then what you'll do, we've done this before. What you'll do is you'll go here. Let me start a new thing. You're going to go to the classroom. And you're going to click on the assignment. And right here, you can do, right here for me, it says edit assignment. For you, if you click this, see for me, I can edit it and change things about it. For you, when you go here, it'll give you a little option right here to turn in some type of an image, and you can upload the image. All right, so that's what you're going to do. If you have questions on how to turn this in as a picture, let me know. But we've already done a few assignments like this, so I'm hoping you get used to this. So turn this in as a picture. Okay, now we're going to do this next skill. So for the next part, atoms, when you see, for example, in the periodic table, when you see right here that hydrogen, it says 1.008, some of you might be thinking, well, there's different isotopes of hydrogen. Some hydrogen has 1 neutron, some has 2, some has 3. How can we just say that hydrogen is always 1.008? The way we figured out, that is the average. Out of the known hydrogens in the world, we average out based on how often we find different isotopes. Based on their abundance, we make an average. So let's do this one. So what we have, atoms are weighed in what's called the unified atomic mass units, AMUs, and elements exist in different isotopes, so we find what are called weighted averages. So here is an example of what you do. You're going to take the mass, you're going to turn the percent into a decimal, you're going to multiply the decimal by the mass of each isotope, and you add the results. Let me give an example. So they tell me that 75.77% of chlorine atoms have a mass of 34.969. So remember the steps. You're going to convert the percent to a decimal. So I'm going to take 75.77 and I'm going to make it. So I'm going to move the decimal over 2 places. So the whole thing's a decimal. 0.7577. And I'm going to multiply that. This is the percentage of this mass. So I'm going to do 75 or 0.7577 times 34.969. Make it big so you can see. Let me just scoop this. We're going to run out of room here. Okay. So you take this first percent, turn it into a decimal, multiply it by whatever that weight is, and then we're going to add it, and we do that for the next one. And then we have 24.23. So make it 0.2423 are going to be 36.966. 36.966. All right, so look at what we have here. You take whatever each weight they give you, and you turn that percentage into a decimal. So we have 0.7577 times 34.969 plus 0.2423 times 36.966. See that? So you take this, make this a decimal, times this weight, plus make this a decimal times that weight. So I'll just pull up the calculator on here. So 0.7577 times 34.969, and we get 26.496. So this is 26.496 plus, let's do the next one. So I'll clear this out. The next one was 0.2423 times 36.966. And so 8.957. So then we'll do 26.496 plus 8.957. We have 34.453. So that is the mass of chlorine if you use those averages. 34.453. All right. All right. And now the last skill that we need to learn. So first off, we need to talk about valence electrons. Valence electrons are the electrons in the outer energy level or the highest energy level. So if you don't make it to energy level 3, but you have 2 electrons on energy level 2, 2 is your outer level, you have 2 valence electrons. If, say, you make it all the way to energy level 4 and you have 6 on level 4, well, then you have 6 valence electrons. So whatever your outermost energy level is, the number of electrons you have out there is your valence electrons. You can do electron configurations to find these. Electron configuration, orbital notation. Look at whatever the highest energy level is. I personally will never, ever, ever do that. Here's why. Here's what I want you to remember. See this 1A right here? Everything here has 1 valence electron. So how many valence electrons does potassium have right here? Okay. Instead of you having to write out the 1s2, 2s2, 2p6 all the way and figure out how many valence electrons this has, just go up here. If it's in the first column, it has all of these guys have 1 valence electron. Go right here, you see 2a. Okay? All of these guys have 2 valence electrons. I want you to go where it's B, 3b, all the way over to, so all these B's right here, from SC over to ZN. Ignore these for now, okay? Valence electrons for these are a whole different monster. We'll do those later. But stay in the A's. Look over here. You have 3a. Guess how many valence electrons everything here has? 3. 4a. How many valence electrons does this column have? 4. 5a. These all have 5. 6a. These all have 6. 7a. These all have 7. And 8a. These all have 8. That will save you literally hours. You don't have to write it out. Do 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. You don't have to do all that, guys. You can just look at this and tell me exactly how many valence electrons they have. And that's a massive shortcut for doing these. How many valence electrons are in argon? Z equals 18. Well, you could write it out. 1s2, 2s2. Let's just do this. Argon right here is in 8a. So how many valence electrons does argon have? It has 8. Has 8 outer electrons. Easy enough. That's the trick I want you guys to use for that. How many valence electrons are in nickel? That's actually, you know what? We'll do this nickel right here. Most of these are only going to have 2. So let's skip nickel for now because I want you to focus on the trick I just showed you. So let's not worry about that for now. But last skill you need to learn is electron dot notation. Electron dot notation is used to represent valence electrons. What you're going to do is you're going to draw the element symbol. So let me erase all this work right here. You're going to draw the element symbol, and then you're going to draw dots around the outside. This is another reason why, instead of giving you a multiple choice lesson where you just turn in the form, I had to have you actually do the work and send it to me. The first 2 dots will always go on the right because they're the S sublevel. And then after that, above, left, and bottom are representing the P. So we're going to have a system in which we do this. The way you do electron dot notations, all right, I would take this and write this down somewhere. You're going to put the symbol here. So let's say X will be the symbol. And then you're always going to put your first 2 dots, dots 1 and 2, will both go on the right. If you need a third dot, you always put it on top. 4th dot is always on the left. 5th dot is always on bottom. Now that the right is full and then these have all had 1, now number 6 goes there, number 7 goes on the left, and number 8 goes on the bottom. This right now is probably really confusing, but the moment you see a couple examples, it's going to become very easy, I promise. So let's look at some of the examples now. I'm not even going to do all these. I'll just do a couple to get the idea. What's the electron dot notation for sodium? Na. Let's look where it's at. Na is right here. It's in column 1A. How many valence electrons did we say 1A has? 1A has one valence electron. So what we're going to do when we do sodium, we're going to do Na. And how many valence electrons did we say it has? It only has one. Look where you always put your first dot. Just put it on the right. So the first dot goes here, and we are done. That is it. All done. This is an extremely important skill for what we're going to be doing in the next couple weeks. So this seems simple now, but make sure you got it down. Let's jump over here. Let's do P, phosphorus. Here it is, P, phosphorus. Where is it? It's in 5A. That means it has 5 valence electrons. So let's do phosphorus right here. What you're going to do, let's draw it. Let's do P. Where does dot 1 go? Always on the right. Where does dot 2 go? Also on the right. Where does dot 3 go? Up on top. Where does dot 4? On the left. Where is dot 5? On the bottom. That right there is what phosphorus looks like. Let me do one more so you get the idea, and then we'll be done. Let's do chlorine right there. Chlorine right here in 7A. So chlorine is going to have 7 valence electrons. So chlorine, where does electron 1 go? On the right. Where does electron 2 go? On the right. Where does 3 go? On top. Notice I'm just following that. 4 on the left. 5 on the bottom. How many am I supposed to do? 7 for chlorine. Why am I supposed to do 7? Because right here, chlorine, because chlorine is in column 7A. So it's supposed to have 7 dots. So we've already done 1, 2, 3, 4, 5, 6, and 7. Boom, there's chlorine. That is it. Please email me if you have any questions, but this is all the skills you need to know. You should be able to complete all the problems. Make sure you do them on a separate piece of paper, and then email me when you are done. Have a great day, and like I said, email if you have any issues.